This is the circuit we are going to use in justifying the power bank and the working principle of the power bank we are about to design. Looking at it critically, there are a lot of components involved, and all these components are going to work together, coupled together as a system to create a 5 volt output. Now let us start with the very first. Now we'll consider the first IC, the major regulator, which is the 7805 voltage regulator. It is a linear voltage regulator that has this basic cost. Any voltage applied at the input, what comes out turns out to be what? 5 volt, with reference to the batteries of the phone that we have within the vicinity, which demand exactly 5 volts for a charging system. That's why we're making use of what? The 7805 voltage regulator. Now for the input, we have 4 sets of lithium-ion battery, 3.7 volts, 3.7 volts, this and this, coupled together. First and foremost, we connected the very first two in parallel, and the very second, this one and this in parallel as well, and then jointed the 2 sets of parallel connection to form a series connection, now creating a total voltage of 7.4 voltage as the total efficient voltage we are using to power the device. Now we have here a regulation in between the positive voltage of the circuit. This is a switching device, and once it is switched on, voltage tends to move towards the voltage regulator. And here we have close to 7.4 voltage, and we cannot direct it to the phone due to the very fact that phone demands maximum value of what? 5 volts, then minimum of 3.7 volts. So having this IC here to regulate it, what turns out to come out here will turn out to be 5 volts. Then we'll ground this to the negative. This is the negative terminal. Now connecting this circuit in this form cannot give us exactly all we desire, since we are aiming at a power bank system. Therefore we put in a 220 UF/16 voltage for filtration and standardizing the voltage. And then we have here, and we have a 220 ohm resistors connected to a LED in order to indicate an indicator for the circuit. And therefore after every 5 volts turning out here, we use this circuit to stabilize the voltage and then directing it to USB output. And that is the simple working principle of the power bank. Alright, at this level we are now looking for a situation or a medium of which we can recharge back the total efficient cell we are using, which is 7.4 voltage. Now how do we do that? Since we desire to charge this, now ordinary charger we see in the conventional society cannot charge this, because the output of those batteries are what? The output is 5 volts, and you cannot use 5 volts to charge 7.4, which alters the principle of charging system. In every charging system, the input charge is supposed to supersede the voltage, the cell of which is tending to charge. So in that system we create a medium this way. Now we plug in close to 14 voltage into this device, and then this device filter it, standardize it, and create an indication that there is current flowing in. Now we put in this diode certainly to block the voltage from this not to come in into this, not to reflect back into the charging system. So this is just a simple schematic diagram of the charging input of this, and onto that we are going to show you a stipulated charger we used in creating that 14 volt. Okay, alright, now what we have in this session is a simple charging system that brings forth 14 volt output. Now how do these occur? Now first and foremost, we are making use of a transformer. Now this transformer, having an input of a 220 volt AC, now steps it down to 8 volt AC, and what we are aiming at is 14 voltage DC. Now what do we do here? We create a Wisdom bridge by putting in diode, 4 diode, to serve as a rectification medium. Now at this point, the 8 volt is converted to 8 volt DC. The 8 volt AC here at this terminal is converted as an 8 volt DC. Now having a bulb, that is a light emitting diode, coupled up with 330 ohm resistance, now to create an indicator that there is current flowing through. Now since we have close to 8 volts, now we then need to step it up, or at least close to 14 volts, which is the desired voltage. Now what do we then do? We then use a 220 volt UF to standardize or filter the voltage and then increase it to at least between the range of 8 to almost 16 volts. That's the essence of putting these 220 UF/16 volts capacitors, electrolytic capacitors. Now all these are the basic principle behind the power bank we've designed, and I would like to go into the practical aspect to unveil to you on how the thing looks like. Alright, we've done the basic work. We've soldered some components and we are going to desolder some and then package it at least for a better fitting. Now looking at these two cell, lithium ion cell, 3.7 volt, 3.7 volt, the two of them are connected in parallel. You can see the plus to plus and the negative to negative. That's what we have in the circuit. Now same is applicable to this, negative to negative and plus to plus. So now what do we then do? We connect the two, that is this and this, connect it in series. Now what do we then have? We created this circuit. This is the voltage regulator as I explained in the circuit. This is the capacitance that rectify that filter, the resistance for the light emitting diode. Then this is the USB output. Now having this to be a 10 UF/16 volt capacitance to standardize the voltage output. Now we have this as a regulator. That's the switch, a simple switch for the regulator. So now when I on it, this light surface light to indicate that there is current coming out from this output. Now let us test. Now the light coming out from this tells us that what there is current flowing in this certain circuit. We are using this whole circuit here to justify what we have in this initial circuit. This circuit, all these here, all these system, all these components placed in here are justified in this certain circuit here. That's the basic one, the major output of the 5 volt regulator. Now let us go over to the next one, which is the charger input for this battery. Now look at it here. This is the component, this is the light emitting diode, the capacitor and the resistance we use just to create the system. And after that we then have the very last one, which is recharging back this once the battery is drained. Now with that we have these components. We have this. Now this is the transformer. These are the two diodes we use for the rectification. This is the transformer. What comes in here is 220 and then is reduced to 8 volts, and then we rectify the voltage and then step it up, or will I say filter and then step up the voltage using this capacitor to increase it. And then this is the indicator we have, that is the green bulb backed up with the resistor we talked about in this circuit. Now all these coupled together is going to form a special fast charge power bank, and we are going to couple everything together, fix it and then see if whether it's going to work. Thank you. Now we've plugged in this. This is the charger, the transformer and the component. Now this is the wire to plug in. Now time to charge. We go into the charger circuit and then plug in. Now the light indicates that the circuit, we are charging the battery inbuilt. That is from this, on the lines of connection, tracing it back. Now I remove, it goes off. Now it's time to charge a device. So now what then do? We then plug in this. Now we look for a device. Alright, we have this phone. Now we plug in to test. And that tells you all you need to know about the device. This device can charge a phone at least within 1 hour interval. This phone will be filled. This is the basic working principle behind a power bank. How to build a power bank, as we explained initially, from the principle, from the charging system, the charger itself, and the charger the main input charger of the power bank. And this all alone tells you that our work works and speaks better for us. And that's it from me. Thank you.